All right, hello everybody. This is Unit 12 review for the test. I'm starting at the very back end of the review and working my way to the beginning because most of my classes missed the last like 3 questions. And this way, those of you that missed those 3 questions can watch the first part, and then if you want to see the rest, you can, but you don't have to. I went ahead and decided to do this recording since I had so many of my students taking AP tests today. So hopefully you'll get this in time to actually watch it and prepare for the test tomorrow. Anyway, all right, let's go ahead and get started. So these are the last 2 questions. You have a conic is given by the rectangular equation. It's right here. What is the general equation of this conic, and then what type of conic will this formula create? You probably want to figure out what type it'll create before you try to figure out the general equation. Honestly, you can do it either way. It's up to you, but the type is probably easiest. Well, if you look at this, because of the format you have here in the rectangular form, because you have 121 here or just any number here by itself and no fractions here, then this is going to be a circle. Okay. And whoops, I forgot to do that. Let's see. Ow, that really hurt my ear. Okay, there we go. It's a circle. All right, so then let's go ahead and figure out the general form of the equation. Well, the first thing you want to do to get the general form is go ahead and FOIL or box the x plus 2 squared. And when you do that, you get x squared plus 4x plus 4. And then the next part, box or FOIL the 4 minus 3 squared. And when you do that, you get 4 squared minus 6y, or 4 squared. You get y squared minus 6y plus 9. And then on the other side of the equal sign, you have the 121. Okay. Now, the problem with, you can't just leave it like this because in the general form of the equation, there's a correct order for everything. And the first term needs to be your x squared, then your y squared, and then your x term, then your y term, and then your constant term with a 0 on the other side of the equal sign. Okay, and so when we did that, we got a negative 108 here. What we did is this 4 plus 9 gave us 13, and then you had to subtract both sides by 121, and that's how we got the negative 108. Okay, so that's the last 2 questions. The next one, a hyperbola is given by this set of parametric equations. So these are the parametric. What is the rectangular form of the hyperbola? Okay, hopefully, guys, everybody remembers that you are only going to be able to use your white notes on the test tomorrow. And I told you several times that you can write whatever you want on those white notes. You guys will most likely want to have all of your parametric, or the standard format for all the different types of conics for each, we want the parametric form for each of the conics on the white notes. You need to write those down because they're not included. All right, so let's do the rectangular form of the hyperbola. Well, we know it's a hyperbola because you have secant and tangent, and we know that the term that has the secant in it, that's going to be your positive fraction, so it should be a positive fraction there. Notice there's no negative signs here. And then it's going to be x minus this value. Well, since it's already negative, then it's going to become a plus. So we have x plus 2 here. And then the 8 is going to be squared to become 64. And then it's going to be minus, because tangent's here, the y fraction will be minus. And then it'll be y minus 3 up top, squared. And then the 10 becomes, 10 squared is 100, and then that all equals 1. Next one. Okay, so this is 4 different questions, all based on this parametric function. What type of conic section is it? Well, you have a cosine and sine, so it's either a circle or an ellipse. If this number is the same as this number, then it would be a circle, but because these 2 numbers are different, then that means we have an ellipse. Okay, what are the coordinates of the center? You get the centers by the number you're adding or subtracting here. And don't forget you have to switch the signs. So this 1, oh no, you don't switch the sign, excuse me. Do not switch the sign with your parametric functions. So it's just going to be 1 and -5. And then what is the eccentricity? Because it's an ellipse, we're going to do, let's see, which fraction. Okay. Let's see. Because it's an ellipse, it can, that's a really big line. Let me make it smaller. There we go. I'm going to try to draw an ellipse. Woohoo. That looks kind of good. Let me see if I can make it better. Recognize shape. There we go. All right, here's our ellipse. The horizontal radius is 9. The vertical radius is 3. So it's going to be, what is it going to be? We're going to do C divided by A to get this. And honestly, I cannot think off the top of my head what C is. But we got this value by figuring out what C was and then dividing it by our A value. So this is our A value, and we have to get C. Well, look in your notes. The formula to find C would be the square root of A squared minus B squared. Don't forget that, minus B squared. All right, you guys have seen that a million times. Absolute value. Remember, you only have to worry about these absolute value lines if your A is smaller than your B, and in this case, my B is smaller than A, so I don't have to worry about absolute value signs. But just be aware you might have to take care of those. You might have a B value here that's bigger than your A value. All right, what's the rectangular equation? I'm just going to uncover it for you. Should be pretty easy. When you're doing the rectangular equations, that's when you're going to switch the signs here. The +1 becomes a -1. The -5 becomes a +5. 3, make sure you square it to get 9, and 9 squares to get 81. Alrighty. Some conic sections are given by these parametric equations. What type of conic section is it going to be? This one, because this is a 9 and this is 9, then you're going to have a circle. With this one, because you have secant and tangent, it's a hyperbola. And then on this one, because you have a different value here than you do here, then you're going to have an ellipse. Okay. Let's see, what parametric equations correctly model the conic given by the rectangular equations? So here's your rectangular equations. You need to figure out the parametric form of these equations. First thing you want to do, figure out what type of conic it is, because you have a minus sign here and here. Both of these are going to be hyperbolas, and then I'm just going to uncover the formulas, and I'll show you where the numbers are from. So this 2 here is from here. Don't forget, when you're going from rectangular form to parametric form, that you need to change the signs here. This is your A squared, so if you just want A, then you have to do the square root of this, and so you get 6. Here's from the Y, you have a -3. Again, this is B squared, so to just get B, it would be the square root of 15. 4 here becomes -4, 13 becomes square root of 13 here, 11 becomes +11, 169, the square root of 169 is 13. Okay, notice I have a secant in my first term over here because the x fraction is positive, and over here the secant is in the y term because my y fraction is positive. Moving on. All right. The reflector in a flashlight is in the shape of a parabola. If the diameter of the flashlight is 23 centimeters and the depth is 11 centimeters, then how far from the vertex should the bulb be placed to optimize reflection of the light? Okay, so I'm going to show you the answer first, and then I'll show you how I get it. Okay, it's always best to draw a little sketch for yourself. You have your little flashlight thing. We're going to set the point here equal to 0, 0. That's your origin. And then your depth here is 11, and the diameter is 23, so the radius is 11.5. You're going to have to take 23 divided by 2, gives you 11.5. That gives you the coordinates 11.5 and 11. set up your not parametric, set up your standard form for the rectangle or for the parabola, and it looks like this. Now, because you have 0, 0 at the origin, your k is 0, and so is your h. You can get rid of those. And then you need to solve for a, so you want to plug in your coordinates that you get here. Your 11 is your y, replacing y, 11.5 is replacing x. To solve for a, you're going to divide both sides by 11.5 squared from here. Once you figure out what a is, you can go ahead and plug it into that focal point formula. Okay, and it's 1 divided by 4 times a. Don't forget, your whole denominator needs to be in parentheses. Super, super important. Lots of people are getting mistakes because they don't put it in parentheses. All right, okay, I'm going to go to the beginning. Whoops, too far. That's not what I want. There we go. Okay, so this is the first problem situation you're going to see on the test, and there are 6 different questions all based on this problem situation. You are going to want to find your A value, your B value, and your C value. Write those down somewhere so that you don't have to keep calculating them over and over again with each question. So the first thing they want you to do is just find an equation to model the orbit of Halleys Comet. And when they ask you to do this, if they don't specify like general, standard, or parametric, just assume it's going to be your standard form, okay? That's the most common one that we work with. All right, so let's see what information they give you. You give you your E value is 0.83, and that the major axis is approximately 39.67 astronomical units, and then that's all we get. So the first thing we want to do is figure out what A is, and to do that you're going to take your major axis, because this is the picture. Please use your diagrams and your pictures. Your major axis is this horizontal here, and so you're going to do 39.67 divided by 2. That will give you your A value. Then use that information to find C. To find C, you're going to do A times your E value. Your eccentricity is right there. So just multiply those two together, and that gives you your C. Once you have C, you can find your B value. B squared equals A squared minus C squared. And if you want to know B instead of B squared, then just square root this, and you'll figure out what B is. Okay, hopefully most of you figure that out. All right. So when you put it in standard form, because we're going to have 0, 0 to be the origin, or the center of the ellipse, and so the formula is just going to be this. This is what your A, the A here, you'll get 19.84. When you do all of this extra stuff, you'll get 11.06. Remember, I'm changing the numbers, but the whole wording and the problem situation is going to be the same. So as long as you know the process, you'll be good. All right, so now we already know A, we already know C, we already know B. So the next couple questions, the apogee, or the farthest point from the sun for Halleys Comet, is approximately how many units, astronomical units? To do that, here's your sun. The farthest point is going to be way over here, so you're going to add your A value plus your C value, since the sun is at one of the focal points. So it's just A plus C. And then the perigee, the closest point to the sun for Halleys Comet, is approximately how far? And if you do all your calculations, you'll get 3.37 astronomical units. To get this, you want to have A, which is this huge distance here, minus your C value here. And that's how you got that. Okay? And then the next two, the distance between foci. Don't forget, the word foci is your plural form for focal points. So what's the distance between the focal points? So if the sun's here, the other focal point will be somewhere around here. And this distance from here to your origin is C. And the distance from the origin to the sun is also another C. So to find that total distance, you're going to add those two together, or just multiply C by 2. Okay, you already know what C is from the very beginning. Now, what's the length of the minor axis? Okay, well, if this is your major axis here, your minor axis is the vertical, so here, which is your B value. You have a B value there and a B value there, so just add them together, please. I do not want anybody to square this. I've had a lot of people square those. You're not squaring, you're just adding. Okay, so to find the length of the major axis, it would be 2 times B, or just B plus B, not B squared. Okay. Last one that we haven't gone over yet is if the center of the elliptical path of Halleys Comet is placed at 0, 0, and the major axis is horizontal, then what are the coordinates for each vertex of the elliptical path? Well, you need to know that the vertices are the points here and here on the minor axis, and then here and here on the major axis. Okay, so basically, whatever this would be, your negative A value would be here, your and then just A here. This one, whatever negative B is for this point, and then positive B for this point. Okay, so your answers are pretty easy, right there. Some of my groups have gotten this wrong were because they switched places here and here, or here and here. Don't forget, A is your X and B is your Y. All right, hopefully this helps you. Anybody that missed my review in class, hopefully this video will help you. Please, please, please watch it, and I will see you tomorrow.